Good afternoon, again, post-dessert afternoon. On to the last session for the afternoon. I'd like to immediately start off and introduce Patrick Sharkey, who will be talking to us about coincidence estimation. Patrick.
Sounds fancy. Something tells me that in this session, I'm not the main attraction. I'm not offended if people stroll in or leave, and I'll try to stick to my time because I want to hear what Luke and Jens have to say, much more than what I have to say. It's a new name, coincidence estimation, for a set of techniques that are used by a lot of people and have been for a long time. So there's not too much new in the methods, except for I think what's new is in, or what's hopefully a contribution is in the way that I'm trying to apply these methods to study neighborhood effects. Coincidence estimation is a set of approaches, can be very general approaches. I'll show you some very specific applications that are designed to exploit the timing of events in order to identify the causal, I shouldn't say, not just the timing, but also the timing and the location of multiple events in order to identify causal effects of exposure to those events in one's environment on individual outcomes, okay? So that's the basic goal. So what I'll do is I'll give some motivation for why I kind of started working on this. I'll give 3 applications. These are all very similar applications for the study of incidents of violence. But then I will, in an attempt to do something new, I've then tried to at least generate some general principles for how this might be applied under different scenarios. So if we have time, I'll get into those as well. I borrowed this graph from everyone else who has presented before me today. But this is I think the reason this comes up is because this is kind of the central theoretical problem that a lot of the literature faces. This claim is much weaker now that everyone before me has solved this problem in one way or another, or has gotten really into the pathways by which a neighborhood might be related to individual outcomes. But I still would make the claim that most of the literature on neighborhood effects is very vague in terms of specifying what it is about living in a disadvantaged environment that influence the behaviors, the activities, the outcomes, the functioning of children. Secondly, what is the temporal relationship between exposure to a disadvantaged environment or advantaged environment and its consequences for child outcomes? Third, what is the process, okay? So even if we know the temporal ordering, how does exposure to an environment then lead to impaired or improved outcomes? So I'm going to focus on particular events occurring in children's environments in an attempt to try to make some progress on these fronts. The focus on events, so this diagram, I'm going to show a lot of these, so let me just explain what it is. So essentially, here we have a timeline, and I have individuals here, and the blue dots are individuals. The timing, where individuals show up on the timeline, just represents when a given outcome is measured. Okay, so think about it as when an interview takes place, when an assessment takes place. Okay, and then we'll generalize a little bit from there. And then the red dots are when an event takes place. Okay, so the events that I'm going to focus on are incidents of violence. We want to focus on when the event takes place and also where the event takes place. Okay, so these are children in a given neighborhood 1 who are assessed over time in that given neighborhood, and then an event strikes down in that neighborhood at a given point in time. And we want to compare both the relative timing of when events and assessments happen, and also the location of where children are and where events occur, in order to generate some inferences about the impact of that event on the child. Okay. So in this sense, my hope is that this allows for a more tangible argument about one specific way in which the environment becomes salient in the lives of the individual, or in the life of the individual. It's only one of many possible pathways, okay? And I fully acknowledge this. This is, Rob's talk was called Big Science this morning. This is little science. This is kind of, I'm trying to develop a much more narrow, but hopefully precise way to identify the causal impacts of this specific pathway by which the neighborhood environment becomes salient. And then the second key piece of this is the focus on timing. Particularly, I'm going to focus on the relative timing of multiple events in order to generate hopefully more convincing evidence on the impact of those events. Okay? And then we can think about this broader as part of the effort to shift away from what might be called an association-based understanding of neighborhood effects toward a process-based understanding. And this is kind of a broad argument about what we mean by events, what we mean by process. But anyway, I see this, this line of work as in line with some broader arguments that Andy Abbott and Hezrum and others have made about moving toward a process-centered view on causality. Methodological motivations. Okay, so the central methodological problem, and this is a much more extensive debate about what exactly is the problem of selection. But that said, selection into different environments and out of different environments remains, I think we would all agree, remains probably the most important methodological problem, at least in terms of identifying the causal impact of that environment on individuals. So most of the neighborhood effects literature focuses on variation in where people live in order to try to gain some traction on the impact of that environment. This shifts the question to the timing of events, okay? So this came up just in Chris's talk in the last session, where the question came up of, well, are kids selecting places to go, and is that exogenous? Well, that's one question, but then a second question, you could kind of, if you focus on the timing dimension, you could argue that, well, kids have selected where they are for whatever reasons, but there's exogenous variation in the timing at which a given child finds himself in that space relative to when other children in the community find themselves in that space. So going to a particular place may have no impact on a child if their enemy is nowhere to be found, but if their enemy is there in the same space at the same time, and if we can think about the relative timing of those two events as exogenous, then we might have more traction to identify what is the effect of that meeting, that interaction on the children. Okay. And then a more minor point about measurement. Here in focusing on, I'm in particular going to focus on environmental stressors. I'm looking at incidents of violence. And here a lot of the literature, particularly in sociology, uses self-reports of A, of exposure to violence, B, life stress. And so here, I find those measures, while useful and while some great work has been done, problematic methodologically in terms of asking people to identify what stressors there are in these lives. So I'm going to shift from a focus on self-reported exposure to environmental stress to a merging of objective sources of data on where people are when they are there and when a potential stressor occurs. Okay. Okay, so I'm going to talk very briefly about three applications of this strategy, focusing on the impact of incidents of violence. The first looks at the effect of local homicides on children's cognitive functioning. Second looks at the effect of local homicides on children's self-regulatory behavior. And then the third looks at the effect of local violent crime on student standardized test performance. Okay, so the first study, and I'm not going to go into any detail unless folks want me to. So the first study is based on data from the Project on Human Development in Chicago Neighborhoods, where, and I really kind of am taking advantage of two key aspects of the study. This is a survey where children were interviewed, and I'm particularly looking at the cognitive assessments. Really? Okay. Okay. That changes things. All right. So what I'm trying to do in this study is to exploit the fact that, A, there was substantial clustering of where kids were, meaning that there's a large number of children within the same neighborhoods. So these are kids within the same neighborhoods who were assessed at different times. I'm taking advantage of that variation in when children were assessed. Okay? And then I'm merging this with data on homicides, on the location and date of homicides in Chicago. And I'm exploiting the relative timing of when homicides occur in a child's neighborhood and when that child is assessed to try to identify the effect of that homicide, exposure to that homicide in the local environment on children's performance on these cognitive assessments. Very quickly, what I found was surprising to me in how robust the results were. Okay, so exposure to a local homicide has a dramatic impact on children's performance on cognitive assessments, particularly African American children in Chicago. Okay, I won't interpret all of these point estimates, but essentially what this is saying is that if there is a homicide that occurs in the child's block group, okay, within 4 days of the assessment, of the date of the interview assessment, a child scores about 0.4 standard deviations worse than other children in the same neighborhood who were assessed at a different time. Okay? So these are all within neighborhood estimates. As the distance between the homicide and the child's residence widens, the effect diminishes. Okay? As the time between the homicide and the interview assessment widens to 7 days, to 10 days, to 14 days, the effect dissipates over time. So timing matters here. Geographic proximity matters here. We then looked at this. Sibel Raver used to be at University of Chicago. Probably a lot of you know her. She's a developmental psychologist. She studies self-regulation, executive functioning. So we use the same approach to look at whether homicides affect self-regulatory behavior, also in Chicago, based on Sibel's Chicago School Readiness Project. We didn't find anything for these two constructs of executive functioning, effortful control. When we looked at attention, these are raters, objective raters of children's behavior during these assessments. Okay, these were done, with a different purpose in mind. This was part of a classroom intervention. We then matched the data that had already been collected to data on homicides. Children who were assessed within a week of a homicide scored more than 1/4 of a standard deviation lower on attention, also substantially lower on impulse control. Okay, so this partially mediates. We also found negative effects on vocabulary test scores, similar to the other study. This partially mediates that. So this is an attempt to explain why it is that children are perhaps performing worse on cognitive assessments. Part of the answer seems to be that there's reduced capacity to maintain attention and control impulses. Lastly, this is a more policy relevant, perhaps, application. And we moved from, this was a study of standardized test performance in New York, okay? So we satisfied Mario's critiques of this literature. We went from Chicago and New York. We covered the entire spectrum of cities. This is a study with Ingrid Gould-Ellen, Joanna Lako, and Amy Ellen Schwartz, where we used data from the New York City public schools and then merged this with data on all violent crimes in New York. And the key advance here is that we were able to go down to the block face level. So we actually looked at whether there was an incident of violent crime on the student's block face, okay, within the week prior to these statewide standardized assessments, okay? Now, the approach is a little bit different here because all students were given the assessment at the same time. Okay, so the variation here is really between students living in a place where there's a violent crime that occurs right before the assessment, and then we compare this to students living in a different neighborhood where there's violent crime in the immediate aftermath of the assessment. So slightly different setup here. What we found, the effects were much weaker than in Chicago, so the overall effect on, we found nothing on math, on their performance on the math assessments. We found a highly significant but small magnitude effect on the English and language arts assessments. But then when we look at whether they passed the exam as the outcome measure, okay, these are essentially linear probability models. Overall, students who were exposed to a homicide just before the assessment were about 1 percentage point less likely to pass the exam. When we looked at race interactions, this is all being driven by African American students, okay? So African American students are about 3 percentage points less likely to pass the exam if they were exposed to a violent crime just before the assessment as compared to students who were exposed to a violent crime right after the assessment, okay? So if we think about the implications of how students do on these exams, not only for their own academic trajectories, but for, you know, teachers, student scores are now published in New York. Schools are evaluated based on the assessments. And there's a broader case for the importance of these findings. This is a very clear way by which disadvantage in the child's community makes its way into the school environment and affects the educational process, okay? Okay, I definitely don't have time to do the methodological setup. So my goal was to provide some general thoughts about how this method might be extended to cover a broader range of scenarios where we have different variation in the timing of events, and events can be seen very broadly or very narrowly, as I've defined them here, and the timing of the assessments. So I'm going to skip the methods piece and just talk very briefly perhaps about these 4 scenarios, okay? We want to consider A, whether there's variation in the timing of the event of interest, and B, whether there's variation in the timing of what I'm calling the assessment. Now the assessment can be, you know, like some of the examples here I use look at birth outcomes. So the assessment timing is when a child was born here. So we can think of these more broadly than my specific applications. Let me talk briefly about these 4 scenarios. So we have one scenario where there's no variation in the timing of the event and there's no variation in the timing of assessment. And this is the weakest scenario for estimating the impact of the event. Here's one example, this recent example that looked at the effect of the Obama election and also the inaugural acceptance speech on African Americans' test performance. Essentially, the strategy here, if there's no variation in exposure, then the strategy we're left with is to compare the outcome before and after the event. If there is variation in the exposure, so for instance, in this paper, the authors argued that whites should not be subject to a change in performance due to the positive image of Obama. So here they're essentially making an argument that only one group is exposed, and here we can compare the difference in outcomes of those exposed and not exposed. We have to think about the threats to this key assumption. The estimated effect may capture secular change. If there's this may be true even if there's variation in exposure. Are you just being nice, or have you flashed the?
We got a few more minutes.
Okay.
Oh, yeah, you got 2 minutes.
Okay, great. Let me give a second example very quickly. This is an example where there's no variation in the timing of event, but there is variation in the timing of the assessment. So an example here is my colleague Florencia Torche's paper, and there are a whole bunch of examples that use this general strategy where the effect of, they look at the effect of a single event, but they use variation, particularly in the literature on birth outcomes. This is a common strategy where you take advantage of the relative timing of when the child was born, essentially, really when the child was conceived. And the strategies here are to, again, exploit the relative timing of the event and the assessment, and then do this among the exposed and the not exposed under the assumption that there is a parallel trajectory of change between these groups. Okay, so if this is not true, then this is a threat to that assumption. If there are different secular trajectories of change for the treatment and control groups, then obviously we have a problem. And in all of these scenarios, if alternative events are occurring at the same time, we're essentially making a bet that we know what the salient event is, when in fact there may be events that are correlated with it or that are happening at the same time. Okay, so that's a risk that we face in any study that looks at the impact of an event. This was a study I talked about, so I won't describe it in any more detail except to say that it's an example where there's variation in the timing of the event, violent crime being the event. There's no variation in the timing of the incident, of the assessment rather. All kids took the test on the same day. I already described our approach. The key threat here is that the potential outcomes of the treatment and control groups are different. In other words, that the relative timing of when the event takes place and when the assessment takes place may not be exogenous. There may be something different about places where there's a violent crime right before this big exam versus right after that we should worry about. And then lastly, when there's variation in both the timing of the event and in the timing of the assessment. And I think this approach, not to toot my own horn, but I think this gives us the most leverage and the most capacity for exploiting these different types of variation in order to identify causal effects that, under reasonable assumptions, we can be pretty confident in. And so the particular focus here, particularly in the neighborhood effects literature, is to look at kids in the same area. So to take away this selection factor and look at kids who have selected the same, whose families have selected the same environment, and then exploit this variation in the relative timing of when the events happen and when the assessments happen in order to identify causal effects. Okay, we still have to assume that the potential outcomes of the treatment and control groups are not different. That is not guaranteed. There could be a reason why some kids were assessed just before an incident of violence and some kids just after. But we can conduct some pretty basic tests to see whether this assumption appears reasonable. Okay. Okay, so I've made the basic claims here. This is a push for specificity. It is a very narrow approach toward estimating neighborhood effects in the sense that I'm only considering one pathway of influence. I acknowledge that. By exploiting timing, I'm not able to look at long-term or cumulative processes, so I acknowledge that as well. What I think it does is it identifies the effects of that one pathway more precisely, okay? And it doesn't resolve all the questions of why these events might affect kids, but at least gives us specificity in terms of mechanism. Okay, and then secondly, my hope is that it allows us to identify the effects of interest, which are the acute effects of exposure to a given event, more precisely and in a more convincing manner. Oh, I guess I should say the limitations. Yeah, that is what I just said, so I'll finish up there. Thanks.
Thank you, Patrick. We move from timing to space. Luke Anselin from Arizona State University, talking about spatial analysis for local area processes. Welcome.
This works, right? Well, thank you. I'm glad to be here. This actually turned out to be a real challenge for me to put this together, because lately this is not the kind of talk I give. I talk about opengeode and cyber infrastructure and open standards for geospatial analysis and that kind of stuff. And when I first spoke with Kate on the phone, I thought, well, maybe I should talk about some work we're doing in my group on comparative methods to deal with spatial dependence in models for count data, counts of events. But then that's too narrow and too technical. So instead, I could have called this random thoughts about spatial analysis and how they pertain to local area processes. But there's a point to it, and I'll end up, and you'll see I'll end up with my CyberGIS science pitch, which I think is I believe is a very strong way to support endeavors like this, endeavors where you bring together people from different disciplines with different vocabularies. As I mentioned to somebody, I learned a lot of new words, who look at very similar problems, but from very different perspectives and through very different lenses. So let me just start with some introduction. What I want to do is define my terms, and several of you have seen this before, and I apologize if it's too familiar, but basically stating what is special about spatial analysis and why should we bother, and what are some of the traps that we can fall into, and specifically what are some issues when it comes to neighborhood analysis that we have to be very aware of. And basically spatial analysis is mapping on steroids. So it's not just a map, it's not just a visual presentation, but you can see it in the context of information science. How do you get knowledge from the data, and what is the methodological support that gets you there? And so technically it's specialized analytical methods to geographic data. And why do we do this? Because there are particular things that come into play when we bring space to the fore. And specifically, this notion that the information content changes when the location changes is very relevant here. And this can pertain to two different things, and they're very different. One is the nature of the data, the nature of the spatial data. You have misalignment between units, overlapping units, school districts, census tracts, they don't always match, electoral wards, they don't always match, change of support problems, things that happen at one scale and are measured at another scale, and various other such things that have to do with the nature of the data. And because of the nature of the data, you have to be aware of it, because the amount of information in the data is not what you think it is. And a lot of spatial analysis and spatial statistics is all about that, making sure that your standard errors are correct and properly reflect the fact that there is dependence and heterogeneity and so on. That's not the more interesting part. Technically maybe, but not substantively. Substantively, we're interested in the use of spatial analysis technique when we're interested in spatial processes. Processes of contagion, diffusion, peer effects, copycatting, and so on. How do we measure the strength of these processes, the spatial extent of these processes, the continuity of these processes, and so on. So let me show you my classic example. This is Milwaukee. Milwaukee is, you are sociologists, you know this, is one of the most segregated cities in the US. This is a real map of the distribution of African Americans by census tract in Milwaukee, okay? This is a statistical analysis of that phenomenon. It's a histogram of the distribution, and you see, there's lots of tracts with very few, and then there's a few tracts with a lot of them. Now, this is Milwaukee as well, but here I have made space irrelevant. I have taken the exact same percentages and randomly moved them around in Milwaukee, and this is the map that you get. This is what we call a spatially random map. The thing is that the statistical analysis of this fake map gives you exactly the same information as for the real map. They're exactly the same. However, spatial measures don't do that. The map is one example, but another example is a measure of spatial autocorrelation, that the extent to which similar locations have similar values. This is a Moran's I statistic for spatial autocorrelation. It's one of the highest I've ever seen. This is Milwaukee. This is the same for the random map. It falls flat. So what's the moral of the story? Spatial analysis matters when space matters. When space doesn't matter, spatial analysis is irrelevant. And so spatial analysis is really a lot of things, and I won't cover all of them. I don't have the time. I will tend to focus on spatial data analysis, which is statistics and visualization, but there's also spatial process modeling, and I noticed a number of people mentioned agent-based modeling, and there's a lot of spatial content, and it's very difficult to do that and have a spatially representative model for agents. And optimization is a whole other area that I won't get into. Now, why is this relevant for local area processes? As we heard this morning, local area processes are inherently place-based. It's all about place, right? It's all about spatial interaction. The data have location in it. Where did this happen? Right? And the areas themselves are spatially defined. I'll get back to that later. It's actually an interesting problem. The extent to which neighborhoods are exogenous or endogenous in the analysis. So a quick lesson of what spatial analysis is about, spatial effects, and what is special about spatial data. I wrote this paper a long time ago, and it still gets cited. It's really two things. One is that everything is dependent on everything else, but closer things more so, which is known as Tobler's law, after Waldo Tobler. That's the notion of spatial dependence, but it's very important because it's a notion that there is a structure underlying the spatial dependence. And it's that structure that we want to get at, and that's a real challenge, especially with cross-sectional data, as I'll point out later. Another one, which is a favorite of mine, is spatial heterogeneity. We heard the term heterogeneity mentioned a couple of times before, so let me clarify what I mean. Spatial dependence, again, we have two types. One is the one that's more interesting, substantive, I call it, is where we really want to know what is going on. And this is tricky. Let me just run ahead. So we're looking at interaction. Interaction is essentially in the n square. It's a flow matrix. It's a matrix. But we have a cross-section of observation. That's linear. It's not a matrix. So how can we extract the structure of this matrix of interaction out of a set of observations that is essentially the square root of what we need to get? And so that's the real challenge, which goes away somewhat with space-time data, with panel data, but not totally. And then the other part, which is the technical part, is spatial correlation dependence as a nuisance, which is where a lot of the statistical models come in. It's essentially about getting your standard errors right. And there's many different ways in which you can do this: Bayesian hierarchical models, simultaneous spatial regressive models, and so on. Heterogeneity is a tricky one because, as Rob mentioned, or somebody, I think it was Rob, if you push this too far, in the end, you end up with individuals, and everybody is different everywhere and at all the time. So no general conclusions at all, let alone quote-unquote laws, nothing that is, can be moved beyond specific case studies. So where do we stop? And also, how do we stop? Are these discrete breaks, and I think this is very relevant in neighborhood research, are there clear breaks between what I call spatial regimes or different spatial entity, or is there smooth transition? The smooth transition is something that a technique like GWR, geographically weighted regression, would pick up, as we saw in Terry's talk. And then again, we have the nuisance part, which is the technical one. A couple of problems. One is, in a cross-section, we can't tell from the pattern what the process is. So this is referred to as the problem of true or apparent contagion, is that you find a cluster, but you don't know whether the cluster is because there is a contagion or because there is a structural difference. Okay. So people have the flu. Do they have the flu because they blew on each other, or do they have the flu because they were all exposed to some agent that is different for that place, right? You can't tell. It's like you watch a football game, you take one picture of the offense, and you have to figure out, is this a running offense or is this a throwing offense? You can't tell. Right? So how do we tell? We tell by cheating, by imposing structure. And where does that structure come from? From us, not from the data. So this is a real challenge in spatial analysis. The other one in practice, and I know many of my students struggle with this, is you can't tell heterogeneity from dependence. And it's the same problem. The pattern doesn't have sufficient information to let you identify the process. So is the process one of dependence, contagion, or is the process one of heterogeneity? The outcome is the same. So you can't roll it back. There's some other things. As I mentioned, we use n-dimensional data to get at n-square interactions. And we tend to, and I actually picked this up in a couple of the presentations, we would just love to get a handle on these dynamic processes. But unfortunately, we don't have the data to do it. We'd have to have the data, one survey, one point in time. We really want to see how this changes over the time, but we can't. So again, how do we get at this? We cheat. We have these extreme assumptions of equilibrium, stationarity. And I remind my students, stationarity is very boring. Stationarity means nothing is changing anywhere. It's all the same. And so, of course, you don't actually assume that for the process at hand. You push it as far away as you can in the error terms. But behind all this fancy spatial analysis are some very weak assumptions, or if you wish, very strong assumptions that are weak in reality, and they often do not stand up. So how do you analyze neighborhoods that are in constant transition with a conceptual framework that assumes an equilibrium? That's a problem. A couple of other problems. So I'm, as many of you know, an advocate for spatial analysis. I've been selling this for years, and I do believe that it brings something to the table. But there are some caveats. And so first of all, there are different ways of dealing with it. I find them all three equally interesting, and I have to do this in opengeode, which is my software, which is now used by more than 70,000 people worldwide. This is built in. It's a transition from visualization through exploration to modeling and regression analysis. Okay? And I firmly believe in that. And of course, I don't see it in isolation. I'd see it as a feedback loop with theory building and theory formulation. But I don't believe in just the last part, which even though I was trained originally as an economist, that's all you learn. You never look at a table, never look at a map. I think it's changing, and it's changing a lot actually. But I believe very much in this feedback between these three aspects. So let me just be a devil's advocate and raise some issues that really affect spatial analysis as it is applied or can be applied to neighborhood processes or local processes. One is the unit of observation, and I'm actually heard this in a number of talks this morning, so it ties with that very nicely. There I mentioned spatial weights. Nobody mentioned them, but you need to mention them. And the notion of spatial scale, which is related in a sense to the unit of observation. So in a neighborhood study, we really need to make a choice. Do we focus on the individual, or do we focus on the aerial unit? And there are different frameworks. I mean, now we have the data where we can do both. We have the data at the individual level. We can aggregate them any way we want. We can superimpose predefined units, or we can define the neighborhoods endogenously from the information that we get. Similarly, do we have the fixed net, the fixed boundaries, or can the boundaries change? In other words, can the neighborhoods change over time, or do we use the same definition that has been used for the last 20, 30 years to look at processes as they change over time? And it's really, you can't do both. Right? Something has to be fixed. Otherwise, you cannot tell what changes. People ask me that often in the context of spatial modeling. You have, let's say, a spatial coefficients and a weights matrix, and you look at change over time. Well, one of the two has to stay fixed. You keep your weights matrix fixed, then you can see if the coefficient changes. Or you keep your coefficient fixed, and then you can see if the weight matrix changes. It's a little trickier, but it can be done as well. But you can't have both of them change, because then you don't know which of the two it is that really drives the change. That's the problem. A third issue, which is a little more technical, and I wish Steve Durloff had the time to show you all his equations, because I have 5 minutes, so I'll go right to the end in a second. But the scale of interaction, is it individual to individual, or as the economists often use in these interaction models, there's a reference group. So the reference group is basically all the other people in the neighborhood, and then there's some kind of average representation of that reference group that influences your behavior. Or is it spatial unit to spatial unit, and what does that mean, right? So we can, since I really don't have the time, let me jump over this. Spatial weights, just a quick mention, there's increasing work that combines geographically defined weights with social network defined weights, and increasingly the information is there to do both of these. Space-time analysis, there's still a problem of what is a proper metric of distance in space-time. Spatial scale, ecological fallacy, I think everybody knows this, but I even have some equations, but I won't show them to you. This is a real problem. Let me focus on new directions. And what I wanted to do here is really raise some issues that I think, not so much issues, these are infrastructure type of ideas that I believe can augment the research on neighborhood dynamics and neighborhood change. One is this notion of data augmentation, and I was very pleased to hear that many people here mentioned, for example, scraping yellow pages and looking at non-traditional sources of data. Unfortunately, the ACS is basically, for my purposes, worthless. You know, so I mean, it's too bad people are voting to eliminate it. On the one hand, I can say, well, you know, it's not so bad, but, you know, you can't eliminate census data. And there's all kinds of new sources of data, from social network sites, Twitter, Facebook, Foursquare, all kinds of things that can be used. Cell phone logs, there's the Media Lab at MIT has some really beautiful maps of cell phone calls. An example I wanted to show you, which you may not be familiar with, is this so-called London profiler built by Paul Longley and Mike Batty at CASA at UCL. And it's basically an information database for London, but it's built from a lot of non-traditional sources. And one of them is this multicultural atlas, which uses a technique where surnames are used to infer the nationality. And so rather than waiting for 10 years until the next census comes around and tells you how the neighborhoods have changed, they can do this, if they want to, every 6 months and rerun the analysis and see the extent to which the neighborhood has changed. It's not perfect, and it's nowhere near as good as a real census, but it is a way to give us dynamics where the census does not, and ACS doesn't really either. Another development is what I call urban informatics. It's also known as smart cities or urban computing or urban analytics. It's part of computational social science. It's this idea that the Atkins Committee pushed forward a few years ago, that computation is really a third branch of the scientific method. It brings together computational models, big data sets, and I wanted to show you an example of something that I ran into recently. It's called, I don't really know how you say it, I think livelihoods, I'm not sure. It's by a group at Carnegie Mellon in the SciLab. And what they do is they define livelihoods, which are neighborhoods, but in a very limited sense, in that it uses Foursquare check-ins. Foursquare is, if you wish, a geographical social networking site where you tell people what you're doing and where you are, and they tell you what kind of stores you can go to and buy all kinds of great stuff. These are matched to Twitter feeds. Now, these are massive data sets. I mean, in their paper, 18 million observations. So, you know, this is not for the faint of heart. And then they use this to generate neighborhoods. And this Pittsburgh is an example. Now, if you look at this carefully and you're used to doing neighborhood analysis, you see this is a bounding box. This is not a neighborhood. This is a bounding box of stores. Because these little dots are the places that Foursquare lets you check in. So it's limited, of course. Who uses Foursquare? You know, my mother doesn't, and so I don't either. And so, you know, there's all kinds of selectivity issues. But again, it's an additional source of information of what is going on in the neighborhood. And moreover, it's dynamic. You can let this run overnight, and you have a new one tomorrow, right? Question then is, how do you analyze it? My final pitch is for CyberGIS Science and CyberGIS, if you wish. It's the use of cyber infrastructure to support spatial analysis. And this is a combination of distributed data, distributed processing, training, all kinds of things. And NCSA, I used to be at U of I, and they call it an end-to-end solution for scientific inquiry. So the cyber infrastructure, you just give them your research question, and they come back with the answer. Yeah, that's the idea. Now, I was going to put in a plug for the Octopus, which is Pycelle. That's the library, the open source library of spatial analysis that we're developing. And we're developing this with an eye towards CyberGIS. We're part of a project. We have moved some of this functionality to cyber infrastructure, specifically manipulating spatial weights, doing local and global spatial autocorrelation, and then we're now moving into some fancy spatial estimators like Spatial Probit. And so the idea is you have to move this to a web service. Major type of computer sciencey questions come into play. Interoperability is the buzzword. How do you get, these are not people, these are programs. How do you get these programs to talk to each other? How do you get the programs to know what is the relevant data to pull from which site to bring to bear to the question that you ask? It's not that easy. And let me push forward. A very important aspect of this is collaborative research communities. And it's a core aspect of cyber infrastructure. Now, in the social sciences, we don't have too many of these. We tend to be lone investigators, but I think when it comes to really big problems like neighborhood transition, you can bring many people together. And I started thinking about this when Kate showed me who else was coming to this workshop and what really was going on in this initiative. And the other day I ran into an example of this. It's called EarthCube. It's an NSF initiative. It's all the buzzword among geoscientists. And if you read this quote, I mean, just put in a different word at the end, and we're in business. It's transform the conduct of research by supporting the development of community-guided cyber infrastructure to integrate information for knowledge management across the social sciences or neighborhood analysis or crime studies, And this is the idea of cyber infrastructure, is to facilitate the interaction, virtual interaction. I mean, this is great having people in a physical room, but they have to get here, right? Virtual interaction, it's much easier to do. So check out this EarthCube thing. It's really kind of interesting who all interacts on there. It's, of course, focused on the geosciences. They're the big data folks. My argument to that, or my response to that, would be that the social sciences are also big data folks. Increasingly, we have multiple sensors everywhere. Everything is geotagged. We know where things happen and when they happen, and in some cases by who they happen, and we need to take advantage of that. 3 challenges. One is methodological. I didn't want to spend too much time on technical details, but you have to analyze this. And the buzzword now is big data, massive data sets, but more so than the massiveness, which isn't really a challenge if you always do the same thing over and over. That's easy. But it's the heterogeneity of the data. So how do you combine census data, which are very reliable, done using well-known historical protocols, with this Foursquare stuff, with all kinds of selectivity bias, and with this other buzzword, volunteer geographic information, where people just put whatever on there, right? Some of it is good, some of it is not. I mean, there's a huge variance. So how do you combine all this thing? Computational, how do you make this operational? I mean, it's all about big iron, but in reality, how do you put this infrastructure into place? And I think the most important one, at least as I get a little older and deal with these different communities, I think is a cultural one. The collaborative paradigm, which is actually much more prevalent in the physical sciences than in the social sciences. And are there any economists in the room? So I can tell an economist joke. You sit far away from me, so. But I used to be at Santa Barbara. I've been in many places, but in Santa Barbara we organized under the auspices of the Center for Spatially Integrated Social Science. We organized a lot of workshops. And the interesting one is that we brought a group of economists together. They were all economists. And they were so pleased with this interdisciplinary workshop. Because one was a labor economist, one was an environmental economist, and so on. So we have to move beyond that. And I think that's a real challenge for this community and for this initiative. Thank you.